Okay. We deploy smart contracts on testnets using Remix. Okay. So maybe it doesn't make sense for me to teach you guys truffle yet. Because if it feels like there's a good 50-50 between people who've used Remix versus truffle or some other coding framework. So let's just stick with, and then actually, if you guys want just one more quick question, if you guys can post, if you've used Chainlink before or you've never used it before, you have no idea what the hell I'm talking about with what even Chainlink is. Never. Okay. Never, not used. Okay. Just starting to explore. Okay, great. Used. Okay. Not used. Haven't used. Okay, cool. And then, all right, one more question. Who here is familiar with what Chainlink even does? If you're not familiar, say like, I have no idea why you're even here. Nope. A little bit. Okay. Not familiar. Know about oracles. No idea. Little. So we have like bring off-chain data blockchain. Okay, that's great. Okay, decentralized oracles a bit. Do you know anything about oracles? Decentralized oracles. I love that answer. Okay, cool. So then let's do this. I'll give the brief rundown of Chainlink, and then we'll go through some examples. And I'd love this to be like a really a workshop, right? So please ask questions. Please jump in. We'll go through some demos. We'll go through some examples, and then we'll try to build some. Cool, like a cool, really simple DeFi protocol. Hopefully, if we have time at the end. Yeah, let's jump into it, and then we'll just do it all on Remix. That way, you guys are familiar. Obviously, everything here will transfer over to your smart contract development framework of choice. One other kind of curiosity: is anyone here familiar with? Is anyone here really solid with Python or really good with Python? Yes, me. Yes. Python for the win. All right, so I'm going to tell you guys something that is going to blow your mind. Check out Brownie because it is a Python smart contract development framework. And if you're like, oh man, truffle and hard hat, these things are crazy. Like, check out Brownie. I absolutely love Brownie. A part of me wants to just use Brownie for this, but I'll drop in the chat. Drop in the chat. Like I wrote a quick tutorial on deploying your smart contracts with Brownie. It's basically like truffle. Get the joke, truffle Brownie, but it's Python. And I absolutely love it. So just dropped it in the chat. If you have questions, feel free to ask there. Also, I'm going to drop the Chainlink developers channel in the chat. And this way, after this, if you guys have any other questions, you can jump to the Discord, ask us a million questions, be it about Chainlink or just smart contract development in general, because I know a lot of us are starting out here. So just kind of briefly, we're going to talk about Chainlink. We're going to kind of go a little bit quicker through this so that we can get to the coding examples and really have this be a workshop. But yeah, so the Oracle problem. So smart blockchains can't access off-chain data. Why? Because they're walled gardens, because they're deterministic systems. Because in a deterministic system, if you're trying to do consensus and you get this variable data coming in, if the API changes, is depreciated or whatever, now all the nodes can't sync up, right? So you can learn a little bit more about kind of how these consensus protocols work. Basically, you can't have random data or changing data a part of your consensus protocol. Otherwise, it breaks cryptocurrency. So that's why there are these walled gardens, and they themselves can't make API calls or connect into the off-chain world. So instead, they have what's called oracles, and these are devices that interact with the off-chain world to provide data to smart contracts. They report the result of the data on chain, so the blockchain can stay deterministic. So they do it in a transaction themselves. They encode the data, put it in a transaction, make that transaction on chain, and so that way the blockchain can just process it as if it's any other transaction. So this is the first part of the Oracle problem. The second part of the Oracle problem, though, is if you do this from a centralized Oracle, you now have a centralized point of failure, right? The purpose of smart contracts is to have these decentralized, superior digital agreements. And the entire logic layer that we're building is decentralized, like, on Matic, Ethereum, Polkadot, whatever. These are all these decentralized logic layers. But if you're getting your data from a centralized layer, then you have a decentralized logic layer, a centralized data layer, and your smart contract is no longer decentralized. Right? If somebody can just turn off your data, or change your data, or tweak your data, or you have to trust that they're going to report honestly, it kind of defeats the purpose of building a smart contract. So, yeah, so these centralized points of failures are huge issues in the smart contract space. So how do we resolve this? We use a decentralized Oracle network. This is a network of Chainlink nodes, where each one of these nodes is an independent operator that independently gets data, reports it on chain. That data is aggregated, and that way we can come to a decentralized data result. That way our logic layer is now decentralized, data layer is also decentralized. So in a nutshell, that's what Chainlink allows. It allows you to bring data and computation onto the blockchain in a decentralized manner. And this really unlocks the functionality of smart contracts, right? Because before, there's this kind of walled garden where it's like, yeah, that happens on the blockchain, like whatever. This brings all that stuff into the real world. And so we can do, anything that we want to do. We can take, we can have smart contracts that can, actually replace real life contracts, because now the blockchain can interact with the real world. So that's the power that we're working with here. Any input, any output, work with anything. And Chainlink has already actually gone ahead and brought together a ton of fantastic node operators, and they deliver what's called price feeds, or data feeds, as they're being called now, because there's more than just price feeds there as well, where if you look at this visualization, each one of these different nodes is an independent Chainlink Oracle or Chainlink node that gets data from a source, plops it on chain. That data is aggregated into a piece of definitive truth on what the data for that asset is. So, for example, here's the price of Ethereum in US dollar. You can see around this like middle thing with the checkbox, there are all these lines with these dots. Each one of those dots is an independent Chainlink node getting data, returning it on chain. And you can see, they each have a different number. Like error stake is 196.54. If you see it like right at the top, a little bit to the left, Fuse 196.717, Figment 196.52. So they're all getting slightly different answers. And we bring it all on chain, we take the median, and now everybody has access to the price of Ethereum in USD. Obviously, this is incredibly powerful because you're getting reliable, decentralized data for your smart contracts. And yeah, like I said, I'm going to skip through, this is really, really, really important because we've seen a lot of protocols say, oh, no, I'm just going to use, my own centralized Oracle. Oh, I'm just going to use this Oracle. And then they get, for lack of a better term, pwned, because getting the secure data is so crucial, right? And it's not even getting pwned, but that's hard and bad. It's just, not having these trust minimized agreements really defeats the purpose of smart contracts, and not having data that's quality enough or robust enough for your contract to even be accurate is terrible. So, Chainlink not only makes your data decentralized and more trusted, but it's also better data, just in general, right? So that there's huge pros here, and DeFi has definitely embraced this and accepted this. I think about $10 billion worth of data right now, or $10 billion USD is being secured by Chainlink oracles. Like protocols like Aave, Synthetics, Loopring, Set Protocol. These numbers at the bottom are not accurate anymore, because the last time I took this photo, it has jumped since then. But this is showing the power of these price feeds here. VRF is kind of the next bit, right? So we have, okay, cool. We have this pre-boxed, decentralized price reference that we can refer to. We have this decentralized data feed. What else can Chainlink do? So Chainlink can also get random numbers and create provably random numbers. Remember, again, blockchains are decentralized, are deterministic systems. Getting a random number in a deterministic system is impossible, basically, right? Because it's a deterministic system. If you know what the random number is, it's not really going to be random. And this is a hard problem in computer science in general. So you can create pseudo random numbers right now, but they have these huge points of risk where either the node operator or the Ethereum node operator or Matic node operator, or whatever the miner is, or even if you're getting your random number from a centralized source, they pretty much have control over your smart contract. So Chainlink VRF provides verifiable randomness and allows your smart contracts to get provably random numbers, which is kind of an insane magic thing that still blows my mind. So, and then last but not least is this end-to-end reliability and this end-to-end, unlimited customizability that Chainlink allows. You can make API calls. You can work with any off-chain data, off-chain computation, whatever you want to do. There's a ton of tools that Chainlink enables that we're not going to go into today, but that's basically the gist. Because it allows you to make any API call. And for those of you who are familiar, API calls are how the internet interacts today. So if you wanted to kick off a job to send a satellite into space, Chainlink could be the one to do that. If you wanted to kick off a job that voted in a presidential election based off a smart contract interaction, Chainlink could do that. If you wanted to alter your smart contract code to depend on who wins the Super Bowl, or who wins the World Cup, right? You could Chainlink could allow you to get that data into the smart contract. So it allows this unlimited customizable functionality, which is incredibly exciting. I went through a lot right there. I really cram-packed it in. Are there any questions? Does anything not make sense? And yes, we're going to go into some demos in just a second.
Patrick, I had one question.
Yes.
So I wanted to ask, you said different nodes aggregate data together. So how is that data aggregated?
Yeah, great question. So right now, the Chainlink network is being upgraded so fast that it's a little bit, the way that they're aggregating kind of keeps changing, actually. So right now, they're doing what's called they're transferring what's called the flux monitor aggregation method to the OCR aggregation method. The easier way to kind of say to look at it is, all these nodes, they respond with their result into a smart contract, and that smart contract, and you can even see it on Etherscan, the smart contract is the one that actually aggregates it. So each one just puts the data on chain. There's a function that says or aggregate data, and then it saves that result into a public variable. Does that make sense?
Yes. Thank you.
Yeah, good question. Thanks for asking. Any other questions before we move on to some examples?
Another one, in this image, it says Oracle responses minimum 14. Is there a reason why you need, is that basically 66% consensus or something like that, that you're looking for when you try to aggregate?
Really good question. Yeah. So this might have moved to the OCR version. So the newer version, that OCR version, is 14. You do need that 66%. Oh, this is so cool. You guys can see in real time. So whenever you see these dots, it means they haven't responded yet. And the reason we saw all of them turn to dots is because a new round got kicked off, and they're all reporting a new price now, which is really cool. And you can see as they turn black, that's them responding. So that was really cool.
Patrick, I had actually one more question.
One second, because I didn't quite answer his question yet. Sorry. What was your question again?
I was just asking if the minimum responses is due
right.
to some sort of consensus. Yeah.
That's right. Yeah, that's right. So I think the minimum responses used to be 11 out of 21. So just a half consensus. I think they're probably moved it up to 14 because in the new OCR version, you do need that 66%. OCR stands for off-chain reporting. And basically it takes the aggregation from being on-chain to being off-chain. The nodes actually talk to each other using libp2p, I believe. They actually talk to each other and they report data in one contract, and they need a 66% actually for the off-chain reporting version of this. So they're probably moved it up in to ready for the OCR rollout. Good question. Really good question. Yeah, who was next here?
So I was saying that I mean, all this process requires a bit of time, right? So, but in a DeFi world, arbitrage is like the big thing. So, if like you are not getting the latest price because I mean, all this process at least takes a minute or two, right? And in that minute or two, if someone is getting their price feed from centralized oracles, their price feed will be like accurate and yours will be a little late. So will there be an arbitrage opportunity there?
Yeah, I see what the question is. So the answer is not really. And the reason for that is, especially with how volatile crypto is and how like this is, so the reason it keeps kicking off, by the way, is because the price is being really volatile. So it keeps getting a new price. And there's this 0.5% deviation threshold. So the price keeps probably moving around 0.5%. So this is something that you have to keep in mind. So if your protocol is tolerant of about 0.5% price differential, then there's nothing to worry about or even talk about here, because it is going to update, with that 0.5% here, and be up to date. So if you have a centralized oracle, could it be a lot faster at the moment? Yes, but these keep getting faster and faster, right? And so that we recently updated deviation thresholds on a lot of nodes to 0.3%, updated some heartbeats to being quicker. As the network matures, these are only getting faster and faster, more and more accurate, and also more cheaper, right? Because if you have your own centralized oracle, so getting your data from a decentralized price feed like this is also way cheaper. Because if you get your data from a centralized oracle, that centralized oracle has to keep making the transactions to update the price on chain itself, and you have to pay for each one of these transactions. In a network like this, the costs are kind of shared with everybody who uses the protocol, and it makes it, and you're using economy of scale to make it even cheaper than using a centralized oracle. So right now, if you use your own centralized oracle, this would probably almost definitely bankrupt you if you were the only one using this, just because of how crazy high gas costs are. But so you need to so it's pretty much infeasible to do it with your own centralized oracle. But yes, these are getting faster and faster, with lower and lower deviation thresholds, with lower and lower heartbeats, so that the data becomes more and more real time. So that's a really good question. That is a really good question. Did that answer your question?
Yes, definitely.
Yeah, that's a really good question. Any other questions?
What is meant by the secondary aggregation parameter? What is heartbeat?
What's that?
What is the secondary aggregation parameter? What is meant by heartbeat?
Yeah, so this basically says if there isn't an update, if the price is stable and doesn't deviate outside of 0.5%, in 3 hours it'll update anyways. So let's say it changes by like 0.1%, it'll update in 3 hours.
Okay, got it. Thanks.
Good question. Any other questions?
Patrick, how much fee does Chainlink charge for getting this data?
Yeah, so this is a really good question. So right now, we can actually go to, and this is the public data, right? This is kind of the pre-box network. Oh, whoops. Right now, if we go to these, we can see this massive list of projects that are sponsoring these protocols. So these are all the different projects that are using this price feed or this data feed, and they're all basically kind of contributing a little bit to use, right? So right now, as the network matures, it's a little bit it's a little bit ad hoc. It depends on the protocol, but as the network scales and matures, it probably won't make sense for the ones who are sponsoring to pay for it for everybody else, because right now, I mean, you can get this data right now. It's just a view function, right? But it's not really fair for them to be paying for everyone's usage. So this might change in the future, but right now you can just go grab the data the ask at the moment is, don't be a rent seeker. If this becomes an integral part to your protocol that's making a ton of money, consider chipping in, because that's also going to help make it more and more secure. So the long answer there is basically, right now you can see it for free, but that might change in the future. So because these guys are paying to keep it up. Does that answer your question?
Yes.
Good question. Any other questions? All right, cool. So let's actually jump into an example of actually working with these. And again, keep questions coming. Ask whatever you want to ask. We're going to stick with Remix, and we're going to stick with the price feeds for a little bit. So price feeds are really, right now, probably the easiest thing to use and the most powerful. Randomness is the second easiest. Using any API is awesome for doing any customizable functionality, but you need to do a couple other things there. So we're just going to focus on price feeds for now. And if you want to kind of go advanced and do some, because using any API is really where you can kind of do crazy stuff, where you can go insane. But using price feeds is insanely powerful, because again, like I said, there's something like $10 billion being secured by these price feeds. These are the data feeds that are powering a quarter of DeFi. So this is a super powerful tool that is getting a ton of use. So what you can do in the docs, you can hit this deploy this contract using Remix. And I've done this a bunch of times, but what will happen is you'll get this price consumer contract, and I want to keep the text kind of big so you guys can see. But this has all kind of the baseline code that you need to work with it. If you're working with Truffle, Hard Hat, Brownie, whatever, you can just copy the code here. The syntax is a little bit different because Remix actually doesn't allow these kind of like, I'm going to call them like Node.js type syntax. But yeah, just to kind of work through the contract a little bit, we're going to import, we're going to import the Chainlink, the aggregator interface right here. And what we're going to do is, we're going to create a variable called price feed. And what we're going to do is we're going to get the aggregator v3 interface of this address. So in this doc here, we can go to the contract addresses, and we can see the different addresses of the different price feeds on different networks. So there's Ethereum, BSC, Polygon, XDAI. And since we're going to be testing on the Coven testnet, let's get, where's ETHUSD? ETHUSD. We'll grab this address right here. And it looks like that's already the address, but we'll pop it in there. If you're using Truffle or Hardhead or whatever, you can also use ENS. So to just like grab the web3.eth.ens.get address, like ethusd.data.eth, right? This will get you that same address, which is really nice. So we're just going to hard code it in here. And then all we need to do is call this get latest price function. So you can see it's a view function. So working with these doesn't, you can just view them, and this returns a bunch of data, and we just want this price one. So this is super simple to compile. We'll deploy it. I don't think you guys can see it, but MetaMask popped up. I'm going to hit confirm. And now we're going to have this this price feed consumer object, and we just hit get latest price, and this is the latest price here. And obviously, this number is really massive. If only Ethereum was that expensive. It's actually because Solidity doesn't work with decimals very well. So this is actually, excuse me, $1,502. And remember, this is the Coven testnet, so the price feeds are a little bit less up to date because of the testnet. So do not use this for any production systems because they are not as robust as the production ones. But that's really the simplest way to look at this and the simplest way to use this. Are there any questions with that? Just like deploying it, working with it from a Remix perspective. Yeah, fairly straightforward. We can move on. So just really briefly, I do want to show you guys the VRF VRF and price feeds. So this is, oh, whoops, this is something that I was working on, sorry. This is the VRF code. It's a little bit different. Instead, what we do is we actually, we deploy it. We deploy our smart contract, and we actually need to do what's called the request and receive cycle. So we need to put out a request to a Chainlink Oracle to get the data. And then that Chainlink Oracle is actually going to respond. So when working with the price feeds, those numbers had already been aggregated and posted on chain. So we could just call that view function. But when working directly with the Chainlink Oracles, which is what we're going to do now, we actually need to emit an event for the Chainlink Oracle to read. It'll then go do whatever we tell it to do, and then it'll return whatever data that we want. So for VRF, that data is a random number. So we can kind of see here how that code works. And then we'll jump into an example, like a real example. That's not a demo. So we pull this VRF consumer base, or we import this. I don't know why it keeps flipping over there. We create some contract variables up at the top here, and then we do our constructor. So we need to get this VRF consumer base contract and give it some parameters, because this is what is going to prove that the random number that we return is actually random. So we need to give it the VRF coordinator address, the link token address, and then what we're going to do is we also need to give it the key hash of the Oracle we're going to work with. So you can basically just find these in the docs. This is the key hash of the Coven VRF Oracle. And then this is new. We also have to send it some link as a fee, right? So anytime you work with the logic layer of Ethereum, you make a transaction, you have to pay ETH. Anytime you work with the Oracle layer of or the data layer of Chainlink, you have to pay a little bit of a link. So this basically sets it up, sets up the VRF consumer base, because again, this is going to be what's going to verify that the number is provably random. And then we're going to call this get random number, and we're going to give it a user provided seed. This seed is going to be used for the Chainlink Oracle to in combination with the key hash to get a provably random number. And these are what this VRF consumer base uses to prove it. And then we're just going to return this function request randomness, which we'll call this fulfill randomness function. And then we're just going to set the random result to this randomness global variable. So I know I kind of sped through a lot of stuff here, but let's deploy it. MetaMask popped up. I don't think you guys can see that. So we're deploying this contract that's hopefully going to give us a random number here. And then what we can do here is we'll see the random result starts off as nothing. I'm going to send this contract some link, because it needs to be funded with link in order to do that request and receive lifecycle. Like I said, I am working with MetaMask right now. I don't think you guys can see it because of how the screen sharing here works, but I've just sent. What's that?
We can see your MetaMask.
Oh, you can't see the MetaMask.
Yeah.
Oh, perfect. Okay, great. Yeah. So I just sent it some link. If you guys can see it, great. We'll even see. All right. Well, I almost sent it some link. It's too fast. Looks like the transaction failed because it's Coven. Yeah. Sometimes the testnets don't work too great, but that's why they're testnets, right? So we're sending it some link. And then whenever this confirms, then we can actually get this random number, because again, we're actually going to be sending, this contract. We're going to be sending the Chainlink node. So here's our contract here. We gave it 4 Chainlink by accident, but now we can actually do this request random number. We'll do like whatever, just some random seed here. Do get random number. MetaMask is going to pop up. We're going to hit confirm. We should see another transaction on here now. Whenever that confirms. any day now. Yeah, and so we actually see that we sent out 0.1 Chainlink token to the Chainlink VRF oracle, and this is what's going to use to make the random number, and it's actually going to return in a second transaction back with the random result. So I don't think this should be up here. Oh, it is up already. But the Chainlink node actually returned this provably random number, which is incredibly powerful because you can make a ton of awesome stuff with this. Are there any questions on that?
How can we get link for testing purpose?
Oh, good question. That's a really good question, actually. So if you go through, any of these beginner walkthroughs, or even just like tokens, there are these faucets. So Coven faucet, we just go here, we copy our address, paste it in, do the captcha, send me 100 link, and now we'll have 100 more testnet link. Or whenever the transaction goes through, we'll have 100 tested for the Coven. So all these different faucets are available here. Working on faucets for some of these other ones. Good question. Any other questions?
Can you tell any use cases about these random number generations, like where they used for?
Yep. So here's one really good one. This is pooled together. What they do is they pool everybody's tokens, put it into some type of interest-bearing application, and at the end of like the week, they pick a random winner from everybody who submitted, and they give them the interest made on all of their money. So they pool together, and then every week one random winner is picked, right? So this is one example of that. I made a Chainlink lottery a while back, where it's just really simple. Every 24 hours or something, it can kick off a lottery, and everybody who puts in can just pick a incorruptible random winner, which is really cool. And here's kind of another one that I also like, especially with all these. All the hype around NFTs, is here. This actually is Dungeons and Dragons NFT. It's actually one of my favorite use cases. So you create random characters that have random stats, right? So different strength, dexterity, constitution, intelligence, wisdom, blah blah blah. Use the random number to create provably random. And the reason that this is so crazy is that this is since you're using the Chainlink VRF to get these provably random numbers, it makes them like provably scarce. Basically, getting a really sick statted NFT is really rare. And then what I love is you can I think there's an OpenSea link somewhere in here. Yeah, there's like an OpenSea link here, and you can see like the stats, like the levels. Here's their charisma, constitution, experience, intelligence, strength, wisdom, and like they have these random stats, which is really cool. So for whatever game you want, whatever whatever game you want, whatever DeFi application you want, random numbers are really really good for a lot of reasons. So getting loot boxes, doing random sampling, there's a ton of reasons. So good question.
All right, thanks.
Any other questions? Oh, sorry, I didn't notice there were some chats. Oh, visible. We can see this, but on the transaction screen, maybe some fish are cool. Okay, yeah. Any other questions? So here's what we can do, because we have 23 minutes left, and I want to make this that just like this is for you guys. We can go over the API calls, or what we can do is we can do just a demo with price feeds or VRF. And let me what would you guys like to see? Go over API calls, or do you guys want to see like a demo with price feeds and VRF? API, okay. What else? API calls would be helpful. API, yep, API, okay. API, okay. Okay, all right, so there's a clear consensus on API calls, so let's go there. All right, cool. So API calls, again, this is like, this is almost like the ground zero function. So whereas the price feeds take a bunch of API calls made by nodes and aggregate it and have it already aggregated, this is what's happening under the hood, right? They're going out, they're making these API calls, they're reporting it on chain. So again, really simply, we have this big button we can click where Remix will pull up and have our stuff in it. Again, I've done this a ton, so I have a ton of these. But we have this API consumer contract here. Yeah, and you can learn more about it here. Again, you can get your testnet testnet link from Fund Your Contract. And this is basically the exact same setup as the VRF with a couple extra pieces to clarify the customization. So we're going to import the Chainlink code here with this import statement. We're going to inherit it. API consumer is Chainlink client. We're going to create some contract variables up top. And now what we're going to do is we're going to create this constructor. So this set public Chainlink token, this only works on test nets. So if you're on a local network, you can just do like address link or something, and then do like I think the command is like set Chainlink token, blah 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 whatever, and then do like link. But yeah, don't worry about this for now. But these are some new things. So Oracle and job ID. So we chose our Oracle before by choosing the key hash. So every VRF node has its own key hash. With Chainlink API calls, every Oracle has its Oracle contract and then a job ID. So what does this mean? Well, when we request our API calls, we actually have to choose the oracles that we want and choose the job that we want. So just like in price feeds, just like how in price feeds, each one of these oracles is responding, we actually have to choose which ones we want to respond. So, okay, let's choose, let's choose this one. Cosmotation mainnet. Let's choose this one. It has its own Oracle address. And when we do these price feeds, we actually choose each node that we want to pull. So this step that we're doing here is like 1/21th of this price feeds, right? So we're going to choose an Oracle, and then we're going to choose the job. So here's an example of an Oracle. If they don't have job, okay. Here's an example of an Oracle, and here's the example of the jobs that they have. So the jobs define what to do, right? So we can say, hey, Cosmo Station, I want to use your Oracle, and I want to use a job that gets me the price of FUSD from CoinMarketCap. So this would be the job that does that. So it has some different tasks or adapters, and we'll go over that in a second. But each one has this node job ID, right? And we can copy that from right here. Okay. So once we have the Oracle address and the node job ID, and then also the fee, which we can find the fee here as well. So this is what's known as a node listing service. This is where nodes go, they list their nodes, they market their nodes, so people can find it and use it. But they choose 0.1 link. And we add in our contract the fee for that Oracle, right? So we have the Oracle, we have the job ID. Great. Now, in order to call this Oracle and call this job, we need to, we're going to define that in this request volume data function. First thing we need to do is we need to build this request object. So we're going to do chainlink.request memory request equals build chainlink request, and this is imported from the code that we imported, and we need to give it the job ID, the callback address, which is the smart contract we want the data to be returned to, and we're going to say address this smart contract, and then we need to choose the fulfill function, because remember how I said we emit an event, Chainlink node grabs the event data, does whatever it needs to do, and returns it. It's going to return it to this fulfill function. So we're going to say this contract dot fulfill dot selector. And if we look down here, there's a function called fulfill. So that's how we define what the callback function is. Once we create this request, we can start adding the parameters to the adapters. Now, what does that mean? So let's take this job, for example. So it gets the price. Actually, let's do a different one. Get 256. Let's get a different job, and let's even just go to Coven. Dark mode. Oh yeah, I didn't know they had dark mode. That's awesome. Sorry. So let's go to a job here. Let's go to the jobs here. Get you in 256. So this is a job that gets makes an HTTP GET call and returns a uint 256. So this is really important, right? Because you need to have the job have the correct return type. So these jobs are basically this combination of these tasks or adapters. So the adapters in here are HTTP GET, JSON parse, multiply. So all these things in here define what this job can do, right? And what order they do them in. So the first thing that this job does is it makes an HTTP GET or an API call, right? And we can see we in this job spec here, or this job specification, there's no parameters that are defaulted. So in our smart contract, we actually have to give it the parameters. So we say, hey, can you make an HTTP GET call to this API? And I think I'm rate limited right now. But normally this is where the response would be. We say, hey, let's make an API call to this API. And what it does, it says, is in this task list, is it takes the result of that API call and passes it to the next adapter. So the next adapter is going to be JSON parse, where we're going to, so you can learn more about the adapters in the documentation. We'll go down to adapters here. Then there's one for path for JSON parse. And to do it, we add this path keyword. So we're going to add path raw FUSD 24 hours. So this walks down the JSON result and gets just the value that we want. So you guys couldn't see it because I'm rate limited right now, so sorry about that. But this is like what the output would look like. So we're looking for this volume 24 hour. It returns this JSON object with this volume 24 hour thing in here, and we want just this value. So we say, hey, walk raw FUSD volume 24 hour and get us that. So we pass that to the next adapter. Then there's a multiply adapter. So it takes the result of that, passes it to the multiply. The multiply adapter is defined by this times thing. So we do request.addInt times, and we add the int here. Once we're done, adding our parameters to the adapters, we just send it off. Send chainlink request to the Oracle address with the request that we just built with the fee, and it returns it on this fulfill function. So let's see what this looks like. So again, we're going to compile. Objective Web 3. Oh, whoops. I actually am going to redeploy because I forgot I added this in. File, yep, redeploy. MetaMask pops up. We're going to deploy here. And then just so that you guys can get familiar with this, so here's the contract here. I am going to hit this request volume data without sending it any link. So you'll see this. If you see this gas estimation errored, this should be a sign, oh, I forgot to send it link, right? Gas estimation failed means that there's not enough token to pay for what you're trying to do. Not enough Ethereum, not enough link, or whatever, or you're trying to do something that costs unlimited gas or something, right? So just be aware that that's what that's saying. Because remember, this is following that request and receive lifecycle. So we're going to send this some link. We're going to send it to link. And again, we're sending it to link just to be safe in case we want to make a whole bunch of API calls. And once it gets sent these link, then we can actually request data from the Oracle that we've specified and get the number. So Now that the link is in here, we can hit this request volume data function, and I'm going to hit confirm. And while it's processing, if we hit volume, right now the volume is 0. If you guys want, we can do any API that we want. So feel free to, like, if you have an API that you'd love to see tested, feel free to drop it in chat, and we'll get it done. I think that might be kind of cool. But again, on this contract, we can check it out here. Again, we can see in the ERC20s, we sent the 0.1 link as the payment to the Oracle, and we'll see a response back, and we can see that the volume is right here. So that's the response from that API call. So that's how we can get literally anything into our smart contracts. Obviously, what a lot of people do is they build their own custom APIs. We call those external adapters, and then they can do whatever they want to do, right? You can allow your smart contracts to do literally anything with this. Are we paying gas fees in Link? No, good question. So gas is actually just gas is just like any cost associated with like running a transaction. So when it says gas estimation, it's actually talking about the ETH gas and the Link gas, right? Because it knows that you need to do ETH gas to do all the Ethereum stuff, but you need Link gas to do all the Chainlink stuff. So you're paying the Oracle Link. So you are paying gas fees in Link, but you're not paying for like the transaction computation in Link, if that makes sense.
So basically we are paying for accessing the API, right? That's what the link is for.
Yeah, so it's a combination of things. So you're paying for accessing the API, you're paying for the node kind of being up and running and being able to process requests. And actually in the second transaction, when it returns the data back to you, the node actually is paying the Ethereum gas. So the link that you pay is also going to cover the gas that it has to pay to return the data.
Okay, and just one more question. Basically, all the oracles have every oracle has a collection of nodes inside it, and we can access each one of those through these API requests, right?
Every oracle has a what?
Has a collection of nodes inside, like multiple nodes inside it, and we can access any one of them using the API.
Every oracle has a collection of nodes inside of it. I'm not sure I'm following.
Yeah, that's what I said. Am I correct assuming that, or is that a wrong statement?
No, that's a good question. So so not quite. So if we go to like, here's like a good example. Like this oracle is like also an example of one node, right? And so you can make your, they have a collection of jobs inside of them. Some of those jobs have APIs that they already have access to. You can also give them the API URLs that you want them to call. But yeah, one oracle generally is also just one node, if that makes sense, or did that confuse it more?
I think I confused jobs and nodes. So basically all of them have different jobs inside of them, right?
Yes, yeah, exactly. So if you, so here's an example of an oracle, and we go to, here's an example of like an oracle. Here's the oracle address. And yeah, inside this oracle, there are all these jobs, right? So the oracles do have to like post the jobs themselves. But oftentimes, if you're looking for some really customized job, you can ask them, hey, can you post a job that does this? You can ask a bunch of them, and that'll be how you create your network. But most of them have kind of these like default jobs, like, right? Like this is a job that makes an HTTP post request and returns a uint 256. This one returns a byte, makes a get call, returns bytes. Post returns a bool. There are a couple of customized ones, like this one returns just weather data, which is really cool. But yeah, good question.
Cool, thank you.
Mm-hmm. Are we paying? Why is it 0.1? So the nodes get to post whatever the cost is. Pretty much the standard at the moment is 0.1 link. On testnet, it's a little simpler. You can just leave it at 0.1 link. On mainnet, it's a little bit trickier. So if you are going to convert to mainnet, you want to reach out to the node operators or reach out to the team to like help make sure that the costs you're putting down are solid. What do you mean we can ask them to do a custom job? Can we ask them to do an arbitrary computation? Yep, yeah, exactly. So like, for example, this is a, maybe that's not a good one. This is, maybe that's not a good one either. So this is a custom job that I made. It's the Twitter Chainlink external adapter. So it allows people to post the status to Twitter. And so to do this, I had to build like a custom API to like for the node operator to use. And then, you just ask them to host it. Say, hey, here's my custom functionality. Can you host this? Or obviously, you can build your own node yourself and add it to it. But then, you definitely still want to keep it decentralized, so you can ask a whole bunch. But anyways, this was some custom computation that I wanted them to do. I wanted them to, post a tweet to a Twitter account, which is kind of fun.
What I meant was you can't ask them to do a custom job that you haven't already set up as a job, right? I mean, let's say you didn't make this Twitter kind of a thing, but I want that job to done. Let's say I wanted to execute something completely arbitrary that's not a part of the job that the node operator currently offers. That's not possible, I assume. That's what I meant when I asked.
Yeah, no, that's a good question. So yes and no. So if you set up an API for it and just say, hey, here's the API, here's what I'd like the job spec to look like, and send it to them, a lot of them would be happy to help you out there. But yeah, you can't.
We need to reach out to the operator externally before we can use it in a code, right? That's what I meant, basically.
Yeah, the answer is kind of, right, because if you create your own API, right, and you just pass that API call into like a job that they already have, like if it's just a HTTP get, you create your own API and you just pass the node that API call, they can absolutely process it. But if like maybe there's some weird tasks that you want to do, or maybe you want to keep your private key safe, that's when you'd reach out to them. But if you don't want to have to reach out to them, you can just like, make it easily digestible in an HTTP get or post request.
Right. You mentioned there about private keys. Let's say I use an API that uses my API key, and obviously I can't put that in my smart contract when I'm doing an HTTP get. What are the ways people do that? Do they contact the operator, make a custom job every time they want to change their API keys or something like that?
Yeah, good question. So at the moment, yes. At the moment, yes. And most of the node operators, they want the network to grow and be powerful. So they're super helpful with doing that stuff. And oftentimes they'll even give some good feedback on like your jobs and stuff. There are plans to build what's called Deco. It's something that's kind of already in process, where you can actually, host your stuff and keep it private still. The issue is, you could always like hash your key and put it on chain, right? But then that's like it's still like a little iffy, because then if somebody, it's there forever, maybe somebody figures it out or something. But that is something you could also do. You could put like a hash on there and only give like the hash decoder to the node operators, whatever you want to do. But yeah, right now the easiest thing that most people do is they just give the key to the node operators.
Okay. I wanted to ask like how the node operators are making money in this.
Yep. Yeah, good question. So they get paid in Link. So that fee that we pay them, they get paid in Link. Make sense?
Yes.
Okay,
yes.
Cool. All right. What do you mean we can ask them to? Okay, yep, we just talked. Do you get extra Link token back, or it will get consumed by the node? If it just gets consumed, what will be the advantage of sending more Link? No. So like you just want to send whatever the cost of the job is. So there is no advantage to sending more Link. Don't do that. Can we perform multiple jobs from a node in a contract? Yes. Yeah, absolutely. So like if we wanted to do, I'm curious if this Twitter thing is up. Maybe we could do like a tweet real quick. Yeah, you can do whatever you want. I think the permissions on it are kind of weird. Oh, that's right. I made the permissions weird, so it probably won't work. But yeah, you could do like, request volume data. You can make like a function called like function, get bool public returns. It's whatever, whatever you want it to do, blah blah blah, and then just have like the fulfill function be like this dot fulfill get bool or something, and then have like a function fulfill get bool or whatever you called it. So yeah, you can do whatever you want to do. Any other questions? All right, cool. So we have 2 minutes left here. Yeah, we got to do kind of a thorough dive on like all the different stuff here. There's I kind of want to point you guys into a couple different directions, because now it's like, okay, cool. Like let me build some crazy stuff with this. If you go to the developers section of blog.chain.link, there are some really cool examples of like building your own whatever, right? Build a vending machine, convert a vending machine to accept cryptocurrency, build a dApp, a Binance Smart Chain, how to use Chainlink with Hardhat, develop a DeFi project with Python. Let's look for, here's that dynamic NFT, working on Matic, building an insurance protocol, connect your smart contract to Twitter, RNG, testing, hardware stuff, get a random number into an NFT, connect the Tesla to your smart contract, build a simple DeFi call option or call platform, getting OAuth and API, making a blockchain voting, the list kind of goes on and on if you're looking for inspiration here. A bunch of good tutorials just to get started, get building something. Obviously, the code's all open source here, so you can always leave an issue, jump into the Discord if you get confused, if you get lost. The community is always looking to get better and always looking to improve. So, are there any? I know we're at time here, but are there any other questions, comments? I can do like another 10 minutes if you guys want to have anything else that you want to see. I can do like a remix or not a remix. I can do like a truffle or a brownie, something. If you guys like to see something like that.
Can you show, like, if we have time, could you show what's the coolest thing you've ever seen built on Chainlink as of now? Like, by far, mind blowing. If we have time, of course. If there's nothing else to be done.
Yeah, no, that's a good question. That's actually like, that's $1 million question. So I mean, it's really hard to say like stuff is cooler than DeFi. The fact that Aave has like almost $5 billion, Aave is so cool, right? Like, and the cool thing about like all these platforms is like GitHub, Aave, this protocol is $5 billion in assets under management. That's like insane. Like you can go to the protocol, right? And like type in Chainlink and like see exactly what they're doing and how they're using it, which is so cool. So I think they are, their borrowing lending platform is awesome. I think Synthetics is super freaking cool. I think I don't think Badger DAO uses Chainlink, but they do use Brownie. So if you're Python and you're looking for some like a cool protocol using Brownie, check out Badger DAO. Yearn.finance, like Nexus Mutual, Loopring, like everything on this list I think is really cool. Now some more niche stuff that I think is cool. These are kind of like just really EtherCats. This is a project that kind of launched a little bit recently. EtherCats.io. So this guy created like these provably random cats. They use the Chainlink VRF to give them like random stats basically, and they're like these crazy like adorable cats that have like the art on these is like so cool, and they're and they're doing pretty well. I think that's really cool. I think Pool Together is really cool. I think anybody who's using the random numbers for stuff is really cool, but The list kind of goes on and on. If you want to see some other cool projects or like some hackathon winners, you can come to the documentation. You can go to example projects. This will show, you know, some winners of past hackathons and what they built. This Link My Ride is obviously really funny and really cool. It's connecting your smart contract to a Tesla to rent out a Tesla. This thing is really cool. Farm together. They don't have the video up, but it allows you to play like this video game and also generate yield in DeFi. I mean, there's so many cool things, so many cool projects, both like just ideas and, you know, real live mainnet projects. So really good question. Really good question. Is there something in particular you like that you get excited about?
That's what I was trying to figure out. I mean, these are use cases we've seen before. DeFi, obviously, everybody knows, but I was looking for something like, you know, you really didn't expect Chainlink to be used there. I think Tesla would be one of them that I really found pretty cool. But yeah, something along the lines of that, yeah.
Yeah, I hear that. So some of the ones that are more interesting that are popping up are like the insurance protocols that are popping up, using like, you know, weather data to build an insurance platform. I think that those are really, really cool. Like Arbel is one of them that's doing that. I think the random and dynamic NFTs is a space that is probably going to see more and more adoption very soon. Like that EtherCats one that I showed, you know, really, really simple, you know, just creating provably random stats for his NFTs, and, you know, they're selling like hotcakes. So I think those are really cool. Something that I saw that was different and I wasn't expecting was somebody used the random numbers to create QR codes and ticket numbers for random cases and stuff. And I thought that was really cool, really interesting. And I forget the name of the project, but they're on mainnet as well. So yeah, so more and more stuff. You know, more and more use cases. I'm a little bit biased, but sorry, I know Denver's jumping in to kick me off.
Oh, that's fine.
There's I gotta, this is my test account, but there are some really cool projects that have done like really random stuff on Twitter, which is a lot of fun. One of the ones was one me and my buddy made, where, like I said, it posted a tweet, or there's another one where it created a provably random number. It was a provably random way to give out like a reward to somebody who retweets your tweet, and or build like an NFT based off of a tweet. But anyways, a lot of really cool stuff. And if you're really looking for use cases, you can check out 77 smart contract use cases. And like, there's just a million things you can do. So if you're really struggling, come here and look at some of the different ideas. A lot of the ones at the top are kind of like finance focused. But if you scroll more to the bottom, can I pull this up? Can I scroll? I guess I can't scroll. But if you scroll to the bottom, there are some other really cool ones. And yeah, here's kind of the a lot of stuff here. Any other thoughts, comments, questions?
I found pretty interesting stuff. We'll definitely explore and then hop onto Discord.
Yeah, for sure. We're always around. So excited to see what you guys build. All right, cool. Well, if that's all the questions, it was great talking. Oh wait, was somebody else about to say something?
Well, I was just saying that I think today even Polygon, which is basically Matic, they made the announcement that the Chainlink VRF is on Polygon now, right?
Oh, I didn't even see that. That's great. Thanks for the tip. Appreciate it. Yeah, I think that's going to be massive too, because Matic is such a cheap gas cost chain. So it's going to be super easy to create random numbers and create all these gaming NFT applications. So to be honest, if I was just joining the space and I wanted to build something, I probably would do something with NFTs right now, because they're really getting a lot of attention. And it's really new to build these dynamic NFTs where they can change. They can, oh, awesome. Thanks for the link. They can change and they can have random numbers, which again creates this provably scarcity which isn't something you see with any other platform. So I think we're starting to see a lot of like insanely cool stuff there.
Yeah, so I think that will be pretty cool. I'm not too sure how much more time Patrick has, but then
I can go. I got 2 more minutes if there's any other questions.
Yeah. Any final questions for Patrick? Okay.
Awesome. Well, I hope you guys all took some value from this. Again, jump to the Discord. We're really just trying to help out the smart contract space in any way we can. So really excited that you guys are all here and learning and looking to build, and hope to talk to you guys soon. Oh, and one other thing, actually, I forgot about this. Chain.link. So we actually just announced our hackathon yesterday, which will be starting in March. If you guys want to take a minute to sign up there, it's going to be an absolute blast. So, and you can take what you learned from here and put it to real use. Or you can also finish up the ETH India hackathon, which is going on right now, which is also fantastic. So,
could you share the Discord link?
Yes, absolutely. Yeah, so if you still have a week, right, Denver? They have a week actually to do ETH India stuff now, right?
Yeah, for ETH India Online, they have until this weekend. So I think, yeah, there are a lot of use cases. Like what I really liked is that 77 use cases article is a gold mine. And I think some really cool stuff.
Yeah, for sure.
Can be built. Yeah.
Awesome. All right, everybody. Well, thank you so much for having me. Looking forward to see what you build, and hopefully we'll talk soon.
Yeah. Thanks, Patrick, for coming over.
Absolutely.
Yeah.
Take care. Bye, guys.